Problems 1 through 3 have so far been nothing new. It's just kind of review of what we've done in class. Problem 4 is kind of the first different proof, and this is one that is like a legit possibility to see on a region. So this is thorough enough where there is some stuff you got to work through. And this is a problem where reading the similarity statement is helpful because that's going to tell you the triangles you need to compare. So the first triangle is triangle HTS. And I'm going to trace that out. And you can see it's this triangle that's overlapping or contained within a larger triangle, HGF. So from H all the way over to G, turning over to F, and then turning back down to H. And we had, when we were solving for missing sides with similarity triangles, this is a problem that we already have encountered, and we, as a reflex, know these things are similar because we can show they're similar with a dilation, right? I can stretch out that inner triangle to overlap perfectly on that larger blue triangle. But that's not the point of this problem. The point of this problem is to prove that these things are similar. It's to take the information they give you such that here's a side of that red triangle, 20. Here's the biggest side, 28 of that red triangle. And then here's the base, which will triangle off. It's 26. And these sides will compare to, like, 28 will compare to or correspond to 42. That 20 is going to compare to this entire side, right, from F to H, which is 10 plus 20, which is 30. And then this base here, well, that's going to correspond to the other base, right? As we saw when we kind of stretched it out, those things land on top. So I've got 3 sides in this red triangle and then 3 corresponding sides in the big blue triangle. So I can see this is already a side postulate. And I'm just going to get started now that I see how to do this. And I'll start with SH over the corresponding side, FH, which would be SH is 20, FH is 30. I know up to this point I've been, reversing the fractions, but I wrote it this way, I'll continue it this way. And this is 2/3, or 0.66 repeating. And when I get them all out, we'll show it on the calculator. The next fraction, now I'm going to just check that off that I've done those. The next one we're going to do are the big sides, 28, right? So I'm going to do T to H, right? TH and GH. Well, those correspond, and that would be 28 over 42. 28 over 42, that's going to equal something. And then the last one would be the bases. T to S, TS over corresponding side, GF, and that would be on the denominator 39, and in the numerator 26, sorry. And I'll check the calculator now. I feel confident that they'll be 2/3 or 0.6. But let's just check. 28 and 42. When we make that into a ratio, yep, 0.6. 26 and 39. When we compare them with the ratio, 0.6 and 20 over 30, just really 2 over 3, which is 2/3, and I know that's 0.6. So, yeah, these things are all equal ratios. So I'm ready to write my similarity proof. I'm going to say this first ratio here. Boom. Ratio of sides, or corresponding sides, is my reason. 2, Here's my next pair of corresponding sides. 2, it's the ratio of corresponding sides. 3, 3, ratio of corresponding sides. And there's a side, and a side. And that's my way to verify I'm good to go. To write this similarity statement, triangle HTS is similar to triangle HGF via the side similarity postulate. Very nice. I'll see you in the next one.